Okay, as you can see, the title of our presentation is Thinking Mathematically at Kingsbury Primary School. We've gone down the action research pathway. So our presentation is going to be about our journey in action research. Now, we've decided to do a bit of a snapshot about what we've been doing. So we're going to be focusing on thinking mathematically and working mathematically. So, as we know with VALS, they've added the importance, or they've added the strand of working mathematically, and everybody realises how important that is in our learning and teaching of mathematics. And it also talks about, or it shows us in education, the shift of teaching mathematics onto the thinking processes. So, at the end of last year, we also did a bit of a reflection about where we were at and what we wanted to achieve. And we decided that we were fairly confident with teaching literacy, but we wanted a bit more direction with teaching numeracy. So, what we've found out with our action research is find out how to do something better. We try it, we share and we refine it, we assess it, and then we document it and use it. So we're in the first year of our maths action research, so we're at the stage where we're finding out how to do things and we're trying it, and we're also doing lots and lots of sharing. What we've looked at with our working mathematically is working like a mathematician. So we've discussed all the different strategies that go along with that. So Steve's put a few up on his presentation. Our presentation, I should say. Things like trying different methods, checking your answers, working backwards, making models. Like, there's just so many. The list just keeps going on and on. So we integrate this into our classroom, and we've got toolboxes with all of these strategies in there. And we've got like our problem-solving processes in our classrooms as well, so that the students can refer to that, and we make our teaching of strategies explicit.
Thanks, Melissa. What we thought would be good to show you now was a short example of the kinds of maths lessons that we've been doing to try and achieve the thinking mathematical goals. So I've taken an example of a closed maths question that you could give to kids. A sheet of sums like that is perhaps an older way of presenting maths to kids, and we've taken that and changed it around a bit to make it into an open question. So we're looking at, can we come up with some pairs of numbers when added together make 11? So we've kind of expanded and made it a bit more of an open question. But then we thought, well, we can take this even further by turning it into a open extended investigation, and then we can start asking some questions. So a couple of questions involving this particular problem are, how many different solutions are there? And how do you know when you've found all of them? So then we're starting to bring in the thinking side of it, working like a mathematician. That's kind of a catchphrase that we're trying to use a lot. What do mathematicians do to solve problems like this? And we're not forgetting that there's still skills that need to be learnt. So kids still need to know how to add and have different strategies for adding. So the skill of addition is still being practiced here, but then we're adding in the thinking and reasoning component, and bringing in the idea of mathematical proof. And that, I think, links to that question of how will you know when you found all the different solutions to this problem. We can then also investigate further and start to fill in this table where we say how many pairs of numbers are there that add up to 11. Okay, and the actual answer to that is there's actually 6. And we have to assume that 10 and plus 1 is the same as 1 plus 10, so because they're a pair of numbers. So there are actually 6 if you include 0 in your calculations. And then we can say, well, what about 12? How many pairs are there for 12? And it actually turns out that there's 7. And then we can ask kids to start looking for a pattern. And you might say that the pattern now is that it's 6, then 7, then 8. But in fact, if you test for the next one, 13, it's 7 again. So then we can say, can you predict what the answer is going to be for any number at all? So one way the class might approach that is to try a few different examples and keep going until they can see a pattern. And maybe you can see a pattern if I show you some more answers there. Can you predict for all numbers? So on the next few slides, I've got some examples of students working out this particular problem.